The Translational Hearing Center is a unique academic center of biomedical research excellence that evolved from the focus of Dr. Zhou, Chair of Biomedical Sciences at Creighton University, to fulfill the long-term vision of Richard Bellucci, an otolaryngology surgeon and a sustaining benefactor of the center.
The future is bright for the center. So much momentum has been created in the last 3 years, but there's a lot of talent that's coming from around the world. And we couldn't be more pleased about the trajectory of where the research is headed and the just incredible outcomes that have been achieved. I'd say within a matter of 5 to 10 years, this will be an international talking point. It'll be a center that is renowned and something that Creighton is going to see just such a amazing impact. It's just fun to tell the story to people who don't know about the research that's happening here at Creighton, for funders who are very entrenched with hearing research throughout the world. This is really putting Creighton on the map, and it's an amazing story to share with the world.
The Translational Hearing Center, collectively called the Center, is a subdivision of the Biomedical Sciences Department, which belongs to the School of Medicine at Creighton University. The center was established in 2019 with the guidance of 4 contributors: then Provost Thomas Murray, Dean Robert Dunley, Jun Zhou, Chair of Biomedical Sciences, and Peter Steiger, recruited to be the inaugural director of the center.
The vision of the center is to really develop new ototherapeutics that will preserve and restore hearing. Quite simply because there are no compounds that can do this. And hearing is such a crucial sense for human communication that we use it every day without even realizing how important hearing is to our sense of communication, social interaction, human relations, and even human culture. Everything is integral to everything that we do. And if we lose that sense of hearing, we begin to lose our sense of place in the world, and cognitive decline sets in.
The overall goal of the center is to build a critical mass of research investigators to identify clinical interventions and candidate compounds of autotherapeutics that preserve and restore hearing and vestibular function.
You can see some individuals when they start to hear, and their life is changed. Their face is lighting up, and they are so excited when they start to hear. They were able to start to communicate. They will be able to integrate it into the society, and they will be able to contribute to what they do to realize their own dreams. I think those are the important things we have to realize. And I'm really excited about that, and I really feel this, responsibility or our mission to contribute to that.
This focus is necessary, as hearing loss affects more than 500 million people worldwide from a broad variety of causes, including noise, genomic and mitochondrial polymorphisms, selected medications, aging and neurodegenerative disease, and drugs or diseases that affect the embryo during pregnancy. The consequences of hearing loss, even mild hearing loss, are profound. In children, hearing loss causes delayed acquisition of listening and spoken language skills, weaker academic and career trajectories, and perhaps most importantly, diminished family and social relationships, all with a socioeconomic loss of more than $1.5 million over that individual's lifetime. Worsening hearing loss in older individuals increases social isolation and depression, fraying psychosocial relationships with an increasing frequency of falls, all accelerating cognitive decline.
Well, I lost my hearing when I was 14 months old through meningitis, and so I hadn't learned to speak yet. Really, I hadn't learned to listen, because we have to learn to listen before we can learn to speak. So I was fortunate because of the University of Manchester, which was my local university. There was a team of scientists that were teaching deaf children to listen and talk. And they spent about 4 or 5 years coaching my mother to coach me and train me to learn to listen and talk. And through that dedication, I learned persistence and resilience. So after I did my schooling in a mainstream school and then university and doing zoology, I realized that I enjoyed doing research. And through that, I really began to understand that my passion for microscopy could be used to study the inner ear. And I started to investigate how aminoglycoside antibiotics, which caused me to lose my hearing, also changed the structure of the inner ear. Not only did I enjoy doing that, I started to understand that I was beginning to investigate how I lost my own hearing. And that was the passion that enabled me to get up every day to continue doing the research that I do.
The Translational Hearing Center recognizes the challenges faced from hearing loss and is determined to move progressively forward in finding ways to help those who suffer. No other center for biomedical research excellence has a focused pharmacological theme to treat these deficits, and we are proud to embody this ambitious approach.
I hope they will be as excited as I am, and they will remember that the Creighton Translational Hearing Center is one of a kind to really focus on translational hearing research, and it will directly benefit both the general population as well as military service members.
The Translational Hearing Center is generously funded by the National Institute of General Medical Sciences. This support has enabled the establishment of 2 key research cores at Creighton University: the Drug Discovery and Delivery Core and the Auditory and Vestibular Technology Core. The Drug Discovery and Delivery Core is dedicated to medicinal chemistry, screening novel compounds, protein-protein interactions, and pharmacokinetic and pharmacodynamic modeling of lead compounds. The Auditory and Vestibular Technology Core enables researchers to obtain high-resolution microscopic images, electrophysiological data, and mass spectrometry of drug distributions. While precursors of these cores existed before the center was established, they have since become more defined in their focus. The center's investigators navigate their research largely through these 2 cores. The Drug Discovery and Delivery Core is led by Dr. Jun Zhou, whose expertise is in molecular biology and drug screens. Supporting him are 2 co-directors, Dr. Alika Dash, with his experience in medicinal chemistry and formulations, and Dr. Shandor Lovash, whose expertise is in molecular modeling.
And in this core, we plan to establish a very unique drug discovery pipeline that will include a number of core services. For example, we will start to help screen drugs that would be very useful for hearing loss. And we also will establish a drug optimization, and we will also test some of those drugs in vitro and in explant as well as in vivo models to further narrowing down the candidates that we identify during the screen. And this sort of drug discovery pipeline will be very unique for the hearing field, in particularly, especially in the academic settings. And we hope that this core will not only help the investigators at the Translational Hearing Center at Creighton and at the Boys Town as well as in the UNMC to fulfill their research purposes, to accelerate their discoveries, but also we can help others outside our Omaha area, for example, nationally or internationally, to help them to realize their drug screens and drug discovery of efforts. So our goal is to really accelerate our entire therapeutic approaches to the hearing research, to help investigators to get over the hump of the drug discovery we call Valley of Death, to help them to realize that they could get their drugs into clinics.
The Auditory and Vestibular Technology Core is led by Dr. David He, who is well known for his expertise in procuring electrophysiological recordings of the auditory system at isolated cell, cochlear, and systems levels. Dr. He is supported by 2 co-directors, Dr. Michael Nichols, with his masterful experience in high-resolution microscopy of the cochlea, and Dr. David Smith, who specializes in mass spectrometry and peptide synthesis.
We have 3 aims for the AVT core. The first aim is to provide state-of-the-art methodologies and instrumentation to faculty conducting auditory and vestibular studies in animal models. The AVT core will support equipment and software development and provide assistance in developing techniques and protocols in the area of auditory and vestibular electrophysiology, molecular biology, imaging, and mass spectrometer. The AVT core will also provide infrastructure necessary to capitalize on emerging technological developments. The second aim is to mentor core users in multidisciplinary research to successfully compete for research funding. The third aim is to develop a sustainable plan to provide core services for new and established investigators beyond COBRE funding.
Importantly, the Translational Hearing Center's primary goal is to recruit new faculty to obtain data that will lead to independent federal funding. The center has recently received a substantial grant geared towards this goal.
We want to recruit people who are experts in their own fields, that are energetic, bright, resourceful, and thinking outside the conventional bounds of wisdom to try new ideas, which is where the innovation lies, to push this field forward, to develop these new strategies and therapeutics to prevent hearing loss.
We have 3 research project leaders. Dr. Teesbeer Carr, focusing on noise-induced hearing loss. Dr. Tal Teitz, identifying mechanisms of cisplatin-induced hearing loss. And Dr. Padmashri Raghunathan, researching fetal alcohol syndrome-induced hearing loss. An additional candidate RPL, Jeffrey North, is working on novel antibiotics that are non-toxic to replace those that cause hearing loss and vestibular disorders. These RPL's research directions will be augmented by their use of the 2 previously described core facilities. In addition, the RPLs will be mentored by experienced center faculty serving as internal mentors and, more importantly, by outside external mentors with translational and clinical expertise relevant to their projects.
I think the center has really propelled Creighton to be on an international stage for top research institutions. It brings in over $10 million in a COBRE grant, the largest gift that's ever been funded to Creighton through the National Institute for Health. But it also legitimizes the work that has been done for so many years. So what it does for Creighton is it legitimizes what we've been doing for so long, but also enables us to recruit the highest talent around hearing research in the world.
The writing of research proposals and manuscripts collaboratively between center faculty forges closer research interactions among laboratories and promotes important connections and partnerships between adjacent schools and institutions in Omaha. This enables accelerated research discovery, growth, and translation to impact human lives in our communities, both locally and globally. Ever motivated by the promise of a future free of the struggles and complications of hearing disability, our investigators remain focused on the overall theme of the center, and that is to develop interventions that preserve and restore hearing loss caused by all manners of etiologies. These broader goals begin as small steps by patient, dedicated scientists in the Translational Hearing Center.
Our goal is to build the faculty of the Translational Hearing Center here at Creighton, to grow to reach a self-sustaining critical mass of researchers here in the Omaha area to develop these ototherapeutics and other clinical interventions that we can use to preserve or restore hearing.